SciCuriousID presents. Every modern society runs on energy. Not ideals, not slogans, energy. In the context of Indonesia's rapid development, this is not abstract. It is the lifeblood of the archipelago. When energy fails, hospitals fall silent, food prices rise, factories stop, and daily life fractures almost instantly. Yet when we talk about energy today, the conversation is often reduced to simplistic colors: green versus black, clean versus dirty, future versus past. But real energy systems do not operate in slogans. They operate in physics, infrastructure, and hard constraints. This series begins with a simple but uncomfortable question. What does energy security actually mean, especially for Indonesia?
Behind every question lies discovery. I'm Saluna, and this is SciCurious, where we uncover the science shaping our world.
Energy security is often confused with renewable energy. But the two are not the same. Energy security rests on three foundations. First, diversification. No nation can rely on a single source without exposing itself to systemic risk. Second, sovereignty. Energy that depends entirely on imports is energy you do not fully control. And third, system stability. This is often misunderstood. It is not just about availability, it is about grid inertia. Energy must be available when needed, maintaining a constant frequency of 50 Hz. Not only when the sun shines or the wind blows. Energy security, in other words, is not an ideology. It is a precise technical system. Indonesia is often described as a resource-rich country, and in many ways, that is true. Yet Indonesia imports around 1 million barrels of oil every single day. Liquefied petroleum gas, LPG, is also largely imported, despite vast domestic gas reserves. Why? Because not all energy resources are interchangeable. The answer lies in chemistry. Most of Indonesia's natural gas is methane, CH4, and ethane, C2H6O, excellent for power generation and heavy industry. However, LPG is composed of propane, C3H8, and butane, C4H10. These are chemically distinct hydrocarbons. Methane cannot simply replace LPG without expensive, complex processing facilities that do not currently exist at scale. Solar power is often presented as extremely cheap, sometimes as low as $40 per megawatt-hour based on LCOE, or levelized cost of energy. On paper, that looks revolutionary. But this number tells only part of the story. LCOE measures the cost of producing electricity at the source, not the cost of keeping the lights on at the consumer end. When electricity arrives unpredictably, the system must compensate with backup generation, massive battery storage, grid reinforcement, and reserve capacity. Once these system-level costs are included, we look at VALCO, value-adjusted levelized cost of energy. Under this metric, the true economic value of intermittent electricity looks very different. Cheap electricity that cannot be relied upon becomes expensive very quickly. History shows that energy crises rarely occur because a technology is unavailable. They occur because systems are poorly designed. Energy transitions are not smartphone upgrades. They are infrastructure migrations, slow, capital-intensive, and unforgiving of error. Ignoring system constraints like grid inertia does not accelerate progress. It merely transfers risk, often to the public. Amid oil deficits, dispersed gas reserves, and still maturing renewables, one fact remains. Indonesia holds 31.23 billion tons of coal reserves. Coal is the only large-scale energy resource Indonesia fully controls. It is not glamorous. It is environmentally complex. But for the coming decades, coal remains the anchor of Indonesia's energy system, providing reliability, domestic control, and time. The real question is not whether coal is good or bad. The question is whether it will be treated as a short-term cash machine, or as a strategic asset managed responsibly while the next system is built. Energy security is not built on imported visions of the future. It is built on honest assessments of what we have today. Every light you see depends on a system that never sleeps. We call it progress. But we rarely ask what it takes to keep it running. This is the dilemma we avoid. Because energy is not optional. In the next episode, we explore why the modern world cannot simply choose to use less energy. Episode 2: A World Addicted to Energy.
There's always more to discover. I'm Selu, and this has been SciCurious. Stay curious, and I'll see you in the next wonder.